Good morning, everyone. Today we're going to talk about the common logarithm, the natural logarithm, and the number e, the magical number e. E is a famous number, kind of like pi. All right. What's a common log? Well, common log is logarithm base 10. Okay, that's when you're finding 10 to the x equals whatever, 100. Yep, or 1,000. So the log base 10, log base 10 of 1,000 equal 3. 10 to the third power equals 1,000. So we'll work with that today. Log base 10. They also call this the rule. For some reason, I don't know. The base is the rule. Okay, what's natural? Natural log is log base e. That is called the natural logarithm. It is written ln. Okay. Who was Leonhard Euler? Leonhard Euler is the guy who discovered the number e. It is, let's see if I got this right, 1 plus 1 over n to the nth power. As n gets bigger and bigger, you would think this number would get bigger and bigger and bigger. But it does not, because this goes going towards 0. You can try this if you want to in your calculator. 1 bracket 1 plus 1 over 2 to the square it. Okay, then try it bigger. 1 plus 1 over 3 to the third power. 1 plus 1 over 10 to the 10th power. 1 plus 1 over 100 to the 100th power. Anyways, he's a very famous mathematician, one of the greatest mathematicians ever to live. He did all kinds of stuff in math, and one thing is he kind of came up with this number. Although you find this number, you find e in nature, the way things grow with exponential growth. You're talking about a lot of natural exponential growth. This number e comes in all the time. It comes out to, you can do it on your calculator. You tell me what it comes out to, okay? Or you can look it up on the internet. Where do we find these? We find an exponential growth. We'll have a couple. The natural log base 10, the common logarithm is used in pH, acidity, alkalinity, chemistry. That's one place it's used. Euler's number, exponential growth, decay, money, interest, continuously compounded interest. Okay, so we'll do a couple problems at the end of the day. All right, let's go into these little example problems we have today, just to kind of, just more about logarithms. Okay, if you have this function, your general exponential function, and this base, my rule is greater than 1, what happens to this function? What happens with f of x? Does it increase, decrease, or stay the same? Well, that's our general like this. The bigger you go, the bigger x gets, the higher this goes. So it's always increasing. All right, 4.4.3. What is the rule? The rule is the base. So what's my base here? 5. A is 5. A equals 5. Okay, so whatever the base is, that's your base right there. A is 5 when you rewrite it, right? Hopefully you guys understand this. E is the natural growth, natural logarithm. That's the base, okay? Log base e is the natural logarithm. Log base 10 is the common logarithm. All right. Let's do a few more here, all in the first one. I know this is going to run a little long, but here we go. Why is log base 2 of 0 undefined? Well, if I try to rewrite this, I got the base. Logarithm is the exponent. I want to, what is the exponent? What does this equal? Why is it undefined? Well, is there any number, any exponent I can take 2 to any exponent to get 0? No. There is no x. There is no x. There is no exponent that will give me so that 2 to the x equals 0. It just can't happen, okay? There's no exponent I can raise 2 to get 0. All right. What about this guy? What's the equation here? Well, there's my x, right? Put it in here. And there's my y. So you're just substituting in here. So log base 10 of 6 equals 0.77815. At the risk of making this a little longer, let's rewrite this just so we understand it again. Base to this power, try this in your calculator if you want to, so this makes a little more sense to you, equals 6. Okay, if I take 10 to this power, I get 6. If I take 10 to the first power, I get 10. Okay, all right. I'll shut up and let you keep playing around with this stuff in your calculator, all right? And we'll use the calculator in just a second. I'll show you where the buttons are if you don't know. Log, okay, so what about this one? Can you do this one? Let's do this without the calculator. Log base 10 of 10 to the negative 8. That means 10 to, I'll rewrite this again because I am fascinated by this craziness. That means 10 to what power? This is what power, log is what power do I take 10 to get 10 to the negative 8? 10 to what power gives me 10 to the negative 8? Well, negative 8. Log base 10 of 10 to the 8 is negative 8, or 10 to the negative 8 is negative 8. All right, kind of tricky. Likewise over here, if I want to rewrite this again, you can always stick this in your calculator now. I'll show you that in just a second. Too long of a video. Here we go. 10 to what power gives me 0.1, or 10 to what power gives me, how can you rewrite this decimal? 1/10. Well, 10 to the negative 1 and flip that 10 over. Okay, that's too long of a video. Thanks for sticking with it, guys.